variations, before we analyze into details what we have to do, it is important to remember the variations that are covered in Form 3. And we cover four types of variations, starting with the first one, which is what we call direct variation. Direct variation. And number 2, we'll cover inverse variation. Inverse variation. And number 3, we'll cover joint variation. Joint variation. And the fourth one will be partial variation. These are the 4 types of variations that are covered in Form 3 mathematics. And it is important you look at each one of them and know where exactly the examiner is going to pose questions from. I will look at each one of them, starting with direct variation. Now, when you talk of direct variation, we are simply looking at 2 variables or 2 quantities that when one quantity increasing in a certain ratio, the second quantity again will increase in the same proportion. If it is decreasing, then the other one also decreases in the same proportion. But when you're looking at direct variation mathematically, then we connect 2 variables. We connect 2 variables. For example, we say 2 variables or quantities, P and Q are in direct variation. If when P increases or decreases, Q increases or decreases in the same proportion. What I mean is, for example, if I have P and Q in this case, if P is increasing, then proportionally Q again will increase. The 2 quantities will be in direct proportion. If Q happens to decrease, then Q will again decrease in the same proportion. That is what we call direct proportion. But we are going to use a variation. I will say in this case that if P is varying directly as Q, then mathematically we express this as P using the variation sign equal to Q. So this means that P is varying directly as Q. But as you all know that the sign alpha used here to symbolize variation has no mathematical equation, then we have to remove this sign. And when we remove the sign alpha, we introduce an equal sign. And since this was not the case before, we bring in a constant of proportionality K with the quantity Q. So it becomes P is equals to KQ. In our analysis of questions, we are going to always see how we determine the value of K, because K here is a scalar that is representing what we call the scalar for proportionality. In this case, what is bringing in the proportion part. If we can take an example of a question of this, if, for example, two quantities, P and Q, are such that P varies directly as Q. We're told when P is 30, Q is 6. So find P when Q is 10. We find P when Q is 10. So this is direct variation, and we are looking at two quantities, P and Q. And P is the one that is varying directly as Q. So we express this as P varying directly as Q. But the sign alpha representing here proportion has no mathematical equation. So we eliminate the sign and bring in equal sign with a constant KQ. And replace in the figures that when P is 30, so we have 30 is equals to Q is 6, so we have 6K. So to get K, we divide both sides by 6, both sides by 6. This cancel out, and so our K is 5. So practically what it implies, therefore, is that P is equals to 5Q. That's what it implies, because originally P was equals to KQ. Now we replace in Q as 10, then P will be, this is when Q is 10, P will be equal to 5 times 10, and that is 50. So that will be the value of P when Q is 10. Let's look at the second one. If we have a second question, we're told that two quantities, again, two quantities, X and Y, are such that X varies directly as the square of Y, directly as the square of Y. When X is 50, Y is equals to 2. Find X when Y is equals to 5. Find X when Y is equals to 5. So in this case, again, we have two quantities, X and Y, but now X is varying directly as the square of Y, so that is Y squared. We introduce the equal sign. X will be KY squared, KY squared. Then replace in the value of X, which is 50. So say 50 is equals to, Y is 2. Now 2 squared times K. This means that 4K is equals to 50. We divide by 4 so that this cancel out. And our K will become 12.5. That is the value of K. And so to get the value of X when Y is 5 again, what we do is we'll say when Y is 5, then X will be, we take K, which is 12.5, we multiply by 5 squared. That is 5 times 5. Multiply by 5 times 5. So that is 12.5 times 25. That is 312.5. That becomes the value of X. So it is simple for direct variation to work out using this procedure. Just know when two quantities are directly varying with each other, then they are related by the expression. If it is, for example, P and Q, it is P is equals to KQ. That is direct variation. Now let's look at the second part, which is inverse variation. In inverse variation, we do the opposite of direct variation. In this case, we will find two quantities, two quantities in which when one quantity is increasing, the second one is decreasing. So they go in the opposite direction. When the other one is decreasing, the second one is increasing. In inverse variation, for example, P and Q, we'll say P varies inversely as the reciprocal of the quantity Q. This is used to imply inverse variation. And so we connect this again, introduce an equal sign, P becomes K over Q. If you compare it with direct it is P equal to KQ. You multiply. But now in inverse variation, now it is K over Q because the two quantities are reciprocals of each other. That when one is increasing, the other one is decreasing and vice versa. So we can take again a question and see how we apply inverse variation. You're told that the variables A and B are such that A varies inversely as the square root of B, When A is 80, B is 16. Then part A, you're told to find the equation, connecting A and B. And part B, you're told to calculate. You calculate the value of A when B is 49. That two variables, A and B, are such that A varies inversely as the square root of B. Then when A is 80, B is 16. So the first question is we find the equation connecting A and B. We'll start with this concept here, that we have A varying inversely as B. That is the square root of B. So we have 1 over root B. And then we bring in the equal sign, equal to K over root B. And substitute in. Where there is A, put 80. So you have 80 is equals to K over the square root of 16. And the square root of 16 is 4. So this implies that K over 4 is equals to 80. So how do you get K? K will become 80 times 4, which is 320. That is the value of K. And so the equation connecting A and B will now be A is equals to K, which is 320, over root B. And that is part A. For part B, we are finding the value of A when B is 49. So we take the equation now, A equal to 320 over root B, and replace in, so A becomes 320 over root 49. That is 320 over 7. And 320 divided by 7, that gives us 45.71. That is to 4 significant figures as our solution. So this is how we work out inverse variation. And then the other one was direct variation. But more importantly is for students to understand how do we work out a combined situation involving both direct and inverse variation. And then from there again, we will look at something we call the percentage change so that we cover the 10-mark part. So that will be now the application of direct and inverse variation. The application of direct and inverse variation. And so I will have this question as our practice question. We can have this one. We are told that the quantities, that is three quantities, x, y, and z are such that x varies directly as the square of y, and inversely as the square root of z. You're told when x is 60, y is 2, and z is 25. Part A of the question is find the value of x when y is 6 and z is 81. Part B of the question, you're told that given that y is increased by 10% when z decreases by 19%, calculate the percentage change in x. Now let's give this 4 marks, and let's give this part B 6 marks. Then we'll work out and see how we get the 10 marks. In this case now, we'll start with the first part, which is to bring direct and inverse variation together. And when we do that, then it will become easier to work out part B and part A. So we'll solve as follows. We are saying that x varies directly as the square of y. So it means y squared. And inversely as the square root of z. We take this alpha out and then have x is equals to ky squared over root z. So that is technically the equation connecting x and y and z. Now we replace in the values. We are told that x is 60, so we'll have 60 is equals to y is 2. So we have 2 squared, that is 4k, and z is 25. Square root of 25, that is 5. To get k, we multiply by 5 over 4. And so our answer k will be 60, because this will cancel out. And then 4 is 1. 4 into this is 15. Sorry, this should be 75. That is 15 times 5, 75. That is the value of k. Now, once we have k, then we get the value of x. And then we'll say when y is 6 and z is 81, then x becomes, we replace in this equation our k, which is 75, we multiply by y squared, that is 6 squared, which is 36. Then we divide by the square root of 81, which is 9. So if you simplify, 9 will cancel 1. 9 in this is 4. Then if you multiply 75 by 4, your answer will be 300. That is the answer for part A to earn you the 4 marks. Part B, we are told now that y is increased. So in this case, we have to understand that there is need for us to know what was the initial value of x. And the initial value of x is k y squared over root z. And at the initial x, every quantity is 100%. And now we have the changes here. We are increasing y by 10%. So we'll now obtain our new x. Will be k. Now y increased by 10, so we end up having 110% means over 100 of y squared over z is decreased by 19. Now we have 81. So that becomes the root of 81 over 100 z. So this gives us 1.1 squared y squared over root of 0.81 z as our new x. So once you have the new x, the question is we determine the percentage change. And so how do you get the change? The change in x is the new x less the initial x over the initial x, and then you multiply it by 100 because you are looking for the percentage change. So replacing in what we have, it's simply 1.1 squared. 1.1 squared, that is 1.21 y squared over the square root of 0.81 is 0.9 root z, because we can't find the exact value of root z. Then we less ky squared over root z over the initial, which is ky squared over root z, then we multiply by 100. So most students get there and they get stuck because they fail to know how to work out these unknowns out. Now, if we have this case, 3 minus 2 over 5, this can be split as 3 over 5 less 2 over 5. Using this understanding in fractions, it simply means that ky squared over root z is a common denominator. And so to use it, we can still write and say 1.21 y squared over 0.9 root z. We divide by this. Now when you divide by this one, it's the same as multiplying by the reciprocal, root z over ky squared. Then we minus ky squared over root z. We divide by this again, means we multiply by root z over ky squared. And then this, all of this is multiplied by 100. And do the simplification. Do the simplification. So this cancel out. The unknowns will all cancel out. That is k. We have k here. This is k. So the k is cancelled. Again, this cancel out. This will cancel out. So we are only left with the numbers, which is 1.21 over 0.9 minus 1 times 100. Minus 1 times 100. That will be 1.21. We divide by 0.9, then we less 1. That is 34.44. 34.44%. And so the percentage change in X after you've decreased Z by 19% and increased Y by 10% is 34.44%. So that's how we work out a combined question for inverse and direct variation. I hope we are together, students. And so number 3 is to understand joint variation. To understand now joint variation. Number 3 is to understand joint variation. In joint variation, we are connecting more than 2 quantities. And it is always easier to understand that joint variation is more the same as direct variation. What is happening in direct variation, we are comparing 2 quantities, P and Q. But when we bring in quantities, 3 quantities where they are connected directly or jointly, then we call that joint variation. For example, or in general, we say that joint variation is given generally in the form simple interest formula, PRT over 100. In this case, we say the interest is jointly varies as the principal rate and time. That is how we interpret the simple interest formula. And so, in the case for quantities P, Q, and R, if P, Q, and R are jointly varying, then we'll say P jointly varying as Q and R. This is jointly varying such that P varies jointly as Q and R. Then we have P varying QR. Again, just as in direct variation, we will have P equal to KQR. So we have now connected P, Q, and R together. But in the case for direct, it could be only be P and Q. P and Q. So joint has to do with more than 1 quantities together. So this is now we have R coming in. We can take one question on joint. A quantity M varies jointly as P and N. When M is 45, P is 3, and N is 2. Find M when P is 10 and N is 25. So these quantities M varies jointly as P and N. Work out its simply as follows, that M varies jointly as P and N. Introduce the equal sign, M becomes K, P, N. And replace in the figures, M is 45 when P is 3 and N is 2. 3 times 2, K. So it means we divide by 6. Divide by 6 so that this cancels out. That K becomes, when you divide by 3, that is 15 over 2, which is 7.5. That is the value of K. And so then it means the equation connecting M, P, and N is equals to 7.5 P, N. And so when P is 10 and N is 25, M will become 7.5 times 10 times 25. So that is simply 75 times 25, and that is 1875. That becomes the value of M. And so, just as I've said, in direct variation, what we carry out when looking at direct variation is the same as in joint variation, only that in the joint variation, we have a comparison of more than two quantities or variables. And so finally, let's summarize partial variation. Let's see the summary of partial variation. Meanwhile, you can be sending out your questions so that we can also respond to them. In partial variation, the general expression of equation in partial variation is this equation, generally expressed in the form y is equals to mx plus c. And last time we looked at that equation when we were looking at gradients and equations of straight lines. And we say that m defines gradient and c defines the y-intercept. So in this case, y partly varies as x and is partly constant as c. That is how we interpret the equation y is mx plus c. So for any case, when you're looking at partial variation, always note that what you'll do is obtain a pair of simultaneous equations, simultaneous linear equations, and solve them. And we said last time that we solve them either using any of the methods. And the method that you can use is either use elimination, if you find that is the simplest. Number two, we can use substitution method. If you find that is not possible, use graphical method. And if you find again it is not possible, use the matrix method. Those are the four methods that we solve linear equations by. So what we'll be doing is we'll be obtaining pair of simultaneous equations, then solve them either using elimination, substitution, or graphical method. So let's do a question on this. We are told that a quantity P partly varies as Q and R. Partly varies as Q and R. When P is 8 Q is 5 and R is 3. And when P is 13, Q is 2 and R is 7. So you're told to find the value of P, when Q is 15 and R is 6. That is partial variation. Always it will give you partial variation will always give two equations. And so let's see what we have to do here. But I've given you the hint of what we do is obtain a pair of simultaneous linear equations and then solve those equations using any of the given method. So in this case, P is partly varying as Q and R. So we'll let P to be equal to, now we're talking of Q, X plus R, Y. Now I've introduced the constants X and Y. So we replace in P is 8, so we'll have 8 is equals to, Q is 5, so we have 5X plus R is 3, that is 3Y. And when P is 13, so we have 13, Q is 2, that is 2X, and Y is 7, that is 7Y. So those are the two linear equations, which we are saying we need to solve them by using either of these methods. So let's try solving this using elimination method. So we will eliminate X. I hope we understand this method. If we eliminate X, then I simply interchange the coefficients so that I will have 10X plus 6Y is 16. And 10X plus 35Y is 65. Then get the difference. 6Y minus 35Y is negative 29Y. 16 minus 65, that is negative 49. So to get Y, we divide by negative 29, divide by negative 29, and this cancel out. Y will become, the negative cancel out, we are left with 1, and then 20 over 29. That is the value of Y. We replace this in the equation, either equation, so that we get the value of X. But 5X plus 3Y is 8. So we'll have 5X plus 3 into Y. Y is 49 over 29 is equals to 8. So we'll have this as 5X is equals to 8 minus, now we have, that is 3 times 49, 147. Then we divide it by 29, 5.05. When you less, you get 2.93. 5X will be 2.93. And so we divide by 5 by 5. When we divide it by 5, then our X is 0.59, which is 17 over 29. 17 over 29. So that is the value for X and Y. So finally, what we need to do is, we are told to find the value of P when Q is 15 and R is 6. So then say P is equals to Q, which is 15, times X, which is 17 over 29. Then we add R, which is 6, times Y, which is 49 over 29. So again, if you do the substitution, multiply by 15, then you add 6 times 49 over 29. And that gives us 1827 over 29, which is 18.93. 18.93 as the value of P when Q is given as 5, when Q is given as 15, and R given as 6. And so that is what we call variations. And we want to sample out what you've been able to send as questions and see where we can help our students who are following the program. There is a student who is saying that repeat on combined and direct variation, specifically on part B question. That is combined, direct, and inverse. Combined, direct, and inverse. I've said when you're looking at direct and inverse, most of the time questions will come from the application part. And in the application part, we combine direct and inverse. And just to summarize for the sake of the student who was asked this, when you're talking about the combined, direct, and inverse variation, it means we are simply working out direct and inverse in the same question. So for example, if A varies directly as B and C, and inversely as C, and inversely as C, then what we write is that A varying directly as B, and when we talk of inverse, we've talked about reciprocal over C. So we eliminate the alpha, and so this implies that we have A equal to KB over C. So this now becomes the equation that you use to determine the value for K and the value for A if there is need for that. There's another one who is saying that repeat on partial variation. Partial variation, for those who are working out partial variation, it is still here. We've said that partial variation is generally given in the form y is equals to mx plus c, of which y varies partly as x and partly constant as c. So in this case, we are saying if you're given a question on partial variation, get to understand the connection between the variables, introduce two constants so that you can be able to form a simultaneous linear equation that you will then be able to solve using either of the methods we've given you. There is someone here asking, My name is Phyllis from Siaya. My question is, this is, we are told that 3 variables, P, Q, and R. P, Q, and R are such that P varies directly as Q. This is from Phyllis. P varies directly as Q. P varies directly as Q. And inversely as the square of R. And inversely as the square of R. When P is 18, so this, what will happen, Phyllis, is that P becomes KQ over R squared. So when P is 18, so we have 18, Q is 24, 24K, and R is 4. 4 squared is 16. If you simplify, 4 here is 4, 4 here is 6. Then this is 2, this is 3. Therefore, K will be equal to 12. That is the value of K. So the question is, find P when Q is 30. Now, when Q is 30 and R is 10, then P will be equal to, we replace in 12 times 30 over 10 squared, that is 100. So this cancels out, and so your answer will be 3.6. So that is your solution. For part B is about the change. You are told that Q is increased by 20 and R decreased by 10. So in this case, what you will do is that if Q is increased by 20, so we'll have this. We will say that the initial P will be equal to this equation as it is. That is KQ over R squared. So the new P becomes, what we do is we increase Q by 20. So we have 120 over 100 K. Then over R is decreased by 10. So we end up with 90 over 100 R, then it's squared. This is 1.2 K, and this is 0.9 squared R squared. So we've said that the percentage change in P will be the new P minus initial over initial times 100. So you have 1.2 K over 0.9 squared R squared, then minus KQ over R squared over KQ over R squared, then times 100. Then you simplify that to get your percentage change. Or somebody else. I'm Peter, and my question is, that is the volume V of a cylinder varies jointly as the square of the radius R and the height. So you need to know what's the formula for volume of the cylinder. Volume of the cylinder. Volume is pi r squared h. So v varies jointly as the square of r, that is r squared, and the height, that is height. Remember, there is a constant pi. So we'll say that now our constant pi becomes our k, that is connecting now the two. If the radius is increased by 10 and the height decreased by 20, so it means v is pi r squared h. So when we increase now, we increase the radius by 10. So we have our new v will be 110 over 100 r squared, and the height is decreased by 20. So now we have 80 over 100 h. So this will be 1.21 r squared times 0.8 h. So 1.21 times 0.8, 0.968 r squared h. So you take the same, the new minus the initial over the initial, then you multiply by 100. So you'll be able to get your percentage change. Let's look at someone else. Patricia is asking if you teach through online. We have someone is finding it's easier, that is from Narok. I think those are questions that you've been able to share out. Let's see this one from Pauline from Kisumu. Pauline from Kisumu asks that a quantity P varies partly as the square of M and N. A quantity P varies partly as the square P varies partly as the square of M, so it means M squared. We give it a constant, so I will let P mx, and partly as N, so we have Ny. P is 3, now we have 3, when M, 3.8 when M is 2, so that is 4x, and N is negative 3. So let's 3y is equals to 3.8. And then when P is negative 0.2, M is 3, that means 9x. And N is 2, so that is 2y. So this is an equation that we also eliminate x. So eliminate x here, have 9 have 4, 3 6x less 2 7y, then 3.8 by 9, that is 34.2, 3x add 8y is negative 0.2 times 4, negative 0.8. Simplify this one. 27 less 8, that is negative 35y. And 34.2 less the answer, that is 35. So it implies that y is negative 1. If y is negative 1, then replace in any of the equation. But 4x less 3y is 3.8. So we have 4x less 3 into negative 1 is 3.8, implying that 4x is equals to, this is positive 3. To the other side, it's less. So we have 0.8, implying x 0.2. So the equation is you find the equation connecting p, m, and n. That equation becomes p is equals to x, which is 0.2, m squared less n. I think, Pauline, that is now clear for you. There are so many questions that we can't handle all of them. Let's look at purity from Nairobi. Given that y is inversely proportional to x and k is a constant of proportionality, so we have y is inversely proportional to x. I believe it is x power n. So this becomes y is k over x power n. If x is 2 when y is 12, then it means that we replace here x is 2 when y is 12. So this is 12 is equals to k over 2 power of n. This means that 2, we multiply by 2 power n, multiply by 2 power n. So this cancels out. Our k is 12 times 2 power n. And again, you're told that when y is 3, x is 4. So we'll say y is 3, k over x is 4, so 4 power n. This will mean that k again is now equal to 3 times 4 power n. So the two equations, we equate the two so that we have 12 times 2 power n should be equal to 3 times 4 power n. We divide the numbers, divide by 3, divide by 3. This cancel out. This is 1, this is 4. So we have when you divide, you get 4. 2 power n times 4 is equals to 4 power n. Bring the 2 powers power n together. That is divided by 2 power n, divided by 2 power n. This cancel out. And 2 power n, this is the same as 2 power 2n. Then we divide by 2 power n. So it means we subtract the powers, that is in indices. So we have 2 power n. So implying that 2 power n is 4, which is 2 power 2, and so n is equals to 2. N is equals to 2. So that we are told to find the value of n. And so if that is n, therefore k is 12 times 2 power n. So 12 times 2 power 2, that is 48. I think that is clear purity. Now we have one last one. No, that is a comment. We have Ferdinand from Bungoma. Given that y varies jointly as x and z square, that should be the square of z. Ferdinand, if y varying jointly as x and the square of z, this is the equation. Y becomes kx z squared. So you replace in the figures. You say that when y is 30, simply have 30. X is 4 and z is 3. So 4 times 3 squared k. This is 9 times 4 is 36. K is 30 over 36 over 36. This cancel out. And so k is equals to That is 5 over 6. So Ferdinand, your question is, you find the value of y when x is 10. Now, when x is 10 and z is 6, then y will be 5 over 6 times x, which is 10, times 36 because of 6 squared. And this cancel, this is 6, this is 300. Okay, they have this one from Michelle from Nairobi. Again, it's about inverse and direct variation. We've looked at that one. So we can look at as many questions as possible. This is Flavian from Kentu Bay. Though the question is not about variation, but it's about algebra. So what you can do, because of time, we will stop there. And we'll look at more questions in our next lesson so that you can respond to all of your questions in variation. Variation is an important area in Book 3 and important in Paper 2 Mathematics. So it's important to revise all the areas that you've been able to raise questions from. So that is enough for today. I wish you a nice day. Continue viewing KUTV Elim Live.